Okay, here we go. Last part of a three-part series. Okay, this is part 3 of 4.7. Um, take notes. Okay, so here in this part where I said that we are going to look at trig and inverse trig combinations. Okay, and so take notes. Make sure you are checking in for attendance. So trig and inverse trig combinations. All right, so we're going to look at three different cases. So here we're going to take a look at um, when we have a numeric result like 7 or square root 3 or something like that, or pi over 6, versus an algebraic result where we have something like maybe square root of 1 minus x squared, where you have variables in your answers. Okay. All right. So let's take a look at this. All right. So let's go ahead and evaluate the following. All right. So we'll take a look at this example here. So here we're going to take the sine of an angle, and that angle is going to be written in the form of a sine inverse problem. Because remember, sine inverse, cosine inverse, and tangent inverse, all of the answers to those are angles, right? So sine inverse of 1/2, your answer is going to be an angle. So that's why we're able to take the sine of sine inverse, because sine inverse, the answer to that, the result of that is an angle. All right, so we work on the inside first. So let's get the sine inverse of 1/2. So when is sine 1/2? At 30 degrees, or pi over 6. Okay, so that's how we're able to do the sine of sine inverse, because the result here is an angle, pi over 6, and now I can do sine of pi over 6, and that answer is 1/2. Okay, so just work on the innermost parentheses. Let's take a look at this one. You can do it the other way too. You can do the sine inverse of a sine. So sine 135 degrees. Okay, because here, if we start on the inside, sine of 135 degrees is square root 2 over 2. Okay. And so now I can figure out the angle sine inverse, where it's square root 2 over 2. And that would be 45 degrees, or just pi over 4. Okay. And let's take a look at this one. Let's do cosine of cosine inverse, square root 3 over 2. Again, cosine inverse, all the inverses are angles. So this here is an angle answer. That's why I'm able to take the cosine of cosine inverse. All right, so let's start on the inside first. So in here, when is cosine square root 3 over 2? That would be at 30 degrees, or pi over 6. Okay. And what is cosine of pi over 6? That would be square root 3 over 2. Okay, and let's take a look at this example here. Sine inverse of sine 210 degrees. So again, work inside the parentheses. All right, sine of 210 degrees. 210 degrees lands in here with a reference angle of 30. Okay, sine here is negative. Sine here is negative. So it's going to be negative 1/2. Okay. All right, so we want to know when is sine negative 1/2, and that would be not at 30 degrees, but negative 30 degrees. So negative pi over 6. Okay. All right, so that's how you do those where you have numeric results. And these are all, these four examples, so these are based off of having those basic angles memorized, sine, cosine, and tangent of all the quadrantal angles, 0, 90, 180, 270, and then the three basic angles, 30, 45, and 60, and then being able to know the ones that have reference angles, 30, 45, and 60, like 150, like 210, like 135. Okay. All right. So now let's take a look at numeric results where we don't have them memorized. So we need to use a triangle. Okay. So let's take a look here. All right. So numeric results. Using a triangle. Okay, so let's go ahead and evaluate the following now. And you'll see it's not anything we memorized, so we're not going to see any like 1/2, square root 3 over 2, square root 2 over 2, 0. Okay, so let's take a look at this first example. Suppose that I want to take the sine of tangent inverse. Remember, all the inverses are angles, they're answers. 3 over 4. We don't know when tangent is 3 over 4. Okay, so we don't have that memorized. Okay, so this is where we're going to have to use a triangle. Okay, so what I'm going to do here is I'm going to draw a right triangle. I'll use theta for my angle. All right, so theta is my angle. And what I do know is that tangent of that angle is 3 over 4. And if you remember SOHCAHTOA, right? Tangent is opposite over adjacent. So the opposite side must be 3 and the adjacent side must be 4. Okay? Opposite over adjacent. So opposite side is 3 and adjacent side must be 4. And then over here, Pythagorean theorem, I can solve for this. It's going to be 3 squared plus 4 squared is going to be, you should know this is one of our basic triangles, but I'll work out the problem anyway. Okay, so we get 5 for that side. Okay. All right, so over here, so when we work this out, so tangent inverse is the angle such that the tangent is 3 over 4. So that angle is just theta. Okay. And then the sine of theta, again, based off of SOHCAHTOA, the sine of this angle is opposite over hypotenuse. So the answer here is going to be 3 over 5. Okay. So that's how we get the ones that we don't have memorized. Okay. Let's try another one. Let's do the sine of cosine inverse of 12 over 13. Maybe you try this one. If you think you're like, okay, I get that. Why don't you go ahead and try this one if you think you understand that one. But if you want to see another example worked out, just stay with me. Okay, so here, here we don't have that one memorized, so I'm going to use a triangle. All right, and again, I'm going to use SOHCAHTOA. All right, here's my angle, right? And cosine is adjacent over hypotenuse. So this is adjacent over hypotenuse. Adjacent side is 12, hypotenuse is 13. So adjacent side is 12 and hypotenuse is 13. And now from Pythagorean theorem, I can find the missing side. Okay, so this side is going to be, maybe I'll call it A. Okay, so A is 13 squared minus 12 squared. This is just Pythagorean theorem. 169 minus 144. And this looks like it's going to be square root 25 again, so 5. Okay. All right. So again, this here is an angle such that the cosine is 12 over 13. That angle is theta. Okay, so let me just write that down. So that angle is theta. And sine of theta is SOHCAHTOA, so opposite over hypotenuse. So that's going to be opposite 5 over hypotenuse 13. Okay, so that's how you get that. All right, so we're getting all numeric answers here. So we're going to take a look at this same sort of method here, but maybe you don't get numerical answers. Maybe you get algebraic answers instead. Okay, so let's take a look at these here where you get algebraic results. But again, we're still using a triangle. Even more so now because we have a bunch of x's and we can't even punch these into a calculator. Okay, so if they say exact value, you're not using a calculator. You have to do it like this method with the triangle. Okay. All right, let's see. Evaluate. Suppose that I have this sine of cosine inverse. Again, all inverses are angles, so cosine x. We don't even have a number. All right, so what's going to happen is your final answer won't be a number. It's also going to have x in its answer. All right, so here's my angle, and I know that, again, we're going to use SOHCAHTOA. All right, so cosine is adjacent over hypotenuse. We only have x here, but remember, this is the same as x over 1. Okay, so adjacent over hypotenuse. So adjacent is x, and hypotenuse is 1. Okay, and then I can solve this side, we'll call it A, by Pythagorean theorem. So this is going to be 1 squared minus x squared. So this is going to be 1 minus x squared. And you really can't do any more with that because it's a variable. And unless you know what x is, you can't go any further than this. Okay. All right. So that's what A is. Okay. So let's break this down. So inside here is the angle, theta. So sine of this theta is SOHCAHTOA, so opposite over hypotenuse. Opposite is square root 1 minus x squared over hypotenuse, which is 1. Okay, but anything over a 1 is itself. So that's just 1 minus x squared square root. Okay. All right. Let's take a look at another one. Again, if you think you understand this one, go ahead and try this one on your own. If not, then just stay with me and follow along. Okay, so again, we have variables here, so we definitely have to do the triangle. And we'll also do our SOHCAHTOA. All right, here's our angle. Okay, and sine is opposite over hypotenuse. So x is opposite, 2 is hypotenuse. Okay, so x is opposite, 2 is hypotenuse. And then I can find this missing side by using the Pythagorean theorem. I'll call this B. So this is going to be square root of 2 squared minus x squared. So that's going to be 4 minus x squared. 4 minus x squared. Here, let me write that a little more clear. Okay. And again, just like the previous problem, there's really not much more you can do with this because we have x is a variable, not a number. And unless you know what x is, you can't do any more with this. All right, so let's go ahead and work this out. So sine inverse is the angle. The angle here is theta. And the cosine of this angle is SOHCAHTOA, so adjacent, square root 4 minus x squared, over hypotenuse, which is 2. Okay, so square root of 4 minus x squared over the hypotenuse, which is 2. Okay, so that would be it. All right, so yay, we are done. So test will be coming up soon. Okay, make sure you are checking in for attendance. Make sure you are keeping up with the homework. Email me or text me if you have any questions.